Okay, today we're going to look at Mock FRQ AB. This covers a lot of different topics. A free response question is not going to have this many questions and have as much work as we're going to see on this problem. But it covers a lot of important concepts in both Calculus AB and BC. Okay, let's read the question. It says, let g be the function defined by g of x is f of x squared minus 5 when x is less than or equal to 3. So this is a piecewise function. G is a piecewise function. And then 5 minus 2x is if x is greater than 3. So this is on the right, this part's on the left. The function g of x has another function defined within it, which is labeled f of x. Okay, the function f, that's this function, is twice differentiable on the closed interval -2 to 10 and satisfies an initial condition f of 6 equals -4. So we'll use that several times. The graph of f prime, so this is f prime. The derivative of the function f is shown in the figure. The graph of f prime has horizontal tangent lines at x equals 2, 5, 8, and 9. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. So let's look at this graph. This is the derivative. So remember, when you have a derivative, your critical values are where it crosses the x-axis. So the critical values of the first derivative are 0, 4, 6, and 9, touches here. And then the horizontal tangents that were mentioned, those are critical values of the second derivative. And then we have area. This is 5, but remember it's negative because it's below the x-axis. 11, 3, but negative because it's below the x-axis. 7, and this little area is 4. Okay, so let's look at the first question, part A. To show that g is continuous at x equals 3. Okay, showing something is continuous is what we call that three-step process. Three-step process for continuity. You're not going to have to write all of this down that I'm writing here. It's just to refresh your memory on what those three steps are. The first thing that we needed to show is g of x is defined. The second thing we needed to show is that the limit from both the left and the right of that value, x equals 3, is the same. So as x approaches 3 from the right of g of x, is the same value as the limit as x approaches 3 from the left of g of x. So we need to show that that's true. And then the last thing that we needed to show, which is kind of trivial once we show the first two things are true, is that g of 3 is equal to the limit as x approaches 3. Remember, 3 by itself means both sides of g of x. Okay, so that's your three-step process. So we're going to do each of those steps to show that the function f is continuous. Okay, so first part. G of 3 we need to show is defined. So g of 3, we look at the function. Here's the function. When x is 3, I need to use this piece. So I'm going to plug in 3 for x. So it's going to be f of 3 squared minus 5, which is f of 4. Okay, well, it's defined, but what is f of 4? Let's see if we can find f of 4. F of 4, we need to use the initial condition because we know that f of 6 is -4, and then we have all the areas in the graph that we can use. So when we're finding a value on a function, we take the initial value, f of 6, and add to it the integral from 6 to this value, 4. Remember, these are upper and lower bounds are x values. This ends up being a y value, which is -4. So we want to find the value of the integral from 6 to 4 of f prime of x dx. F prime of x is our graph. Now the only problem here is that our lower bound is a higher number, so we need to switch that. And then I know f of 6, the y value is -4. This is the y value, these are x values. And then I'm going to reverse that integral and negate it. So now I'm going to go to the graph, and I need to find the value or the area bounded by the graph, or the number from 4 to 6. So if we look at that graph, from 4 to 6, the area is 3, but since we're just looking for a value, we know it's negative because it's under the x-axis. So this is going to be negative 4 minus the minus 3, which is negative 1. Okay, that's the value of f of 4. F of 4 is negative 1, which implies that g of 3 is negative 1, therefore defined. Very abstract way of finding that value, but we look at that so that you understand where all those numbers come from. Okay, now let's look at the second part, and that's to show that the limit from the left and the right are equal. So the limit as x approaches 3 from the right of g of x. Well, how do I find that? Well, we need to look at the function. 3 from the right is this piece here. So we're going to plug in 3 for that piece. So that's 5 minus 2 times 3, which gives us negative 1. Alright, and now let's check the other side. The limit as x approaches 3 from the left of g of x. Well, that's this piece, and I just found that value, didn't I? G of 3 ended up being negative 1. Okay, so part 2 is satisfied. And now let's look at the third part, which is just a formality. We're going to write this down. We need to say that g of 3 is equal to the limit as x approaches 3 of g of x. Well, I know g of 3 is negative 1, and I just found the limit from the left and the right was the same number, so that checks out. Therefore, g of x is continuous at x equals 3. Okay, so that's part A.